The spreadsheet that we're going to be working on today is all about unit analysis, if you hadn't guessed. And what unit analysis is it's just converting from one unit to other units. And for some things, it's really simple, right? If you want to convert feet to inches, that's one that we're all pretty familiar with. There's 12 inches in 1 foot. So you could probably do that one. But sometimes you need to do more than one step to convert from one unit to another. And so that's kind of what this walks you through. So there are 3 things. I'll just say this up front. There's like 3 things that this will be graded on. The first one is going to be the correct answer. The second one is going to be sig figs, which we talked about this morning. The third thing is going to be units. All right, so for every single answer in here, you should have the answer, you should have the correct number of sig figs, and you should have the right units on it. But there's a couple things that we have to cover first, sort of briefly, before we hop into this full stop. So we talked about this morning sig figs, and when you do any operation like multiplication or division, right? So if you do multiplication or division, let's make a number here. So 13.3. Actually, let me make my life easier. Let's say it's 10.0 times 3.00. So our answer would be 30, is what our calculator would say. But how many sig figs should that answer have? 3. I've heard a lot of numbers. It should have 3. So multiplication or division, and I know you just got this morning, but it's based on the smallest number of sig figs that you're multiplying or dividing. So this has 3 sig figs because 1 is a non-zero number, and these are trailing zeros, and we have a written decimal point. This is 3 sig figs also because written decimal point, non-zero number, written decimal point, and then trailing zeros. So the answer should be 30.0. And then you should really convert this into scientific notation, so it would be 3.00 times 10 per second. Okay, so what happens if we add or subtract numbers? So if I took these same numbers and I say 10.0 plus 3.00, when we add or when we subtract, it's not about sig figs anymore. We're not counting the number of sig figs in 10 or in 3, but it's the number of decimal places. So add or subtract. So the smallest number of decimal places. All right, so how many decimal places does 10.0 have? 1 decimal place, right? There's only one number, one significant number after the decimal. So it's one decimal place. And then for 3.00, yeah, 2 decimal places. So if I add these together, we get 13. And how many decimal places should I have? 1. Mm-hmm. Fewest, smallest number of decimal places. This would be 13.0. So same thing if I was to subtract. Do I want to go there? Yeah, I think it would be good. Well, let's just do this. Okay. subtracting these numbers, how many decimal places does 5.01 have? 2. How many decimal places does 0.01 have? Still 2. This is, well, how many sig figs is this? 3, right? How many sig figs is this?
2.
1. These are still leading zeros. So 2 decimal places though, okay? So yeah, decimal places is all that matters here. So our answer should be 5.00. That is the same number of decimal places as the smallest number of decimal places in our math. Let me see. Okay. And then very quickly, so that really is it for adding and subtracting. The trick is remembering the difference, I think, between significant figures and decimal places, and when you use one and when you use the other. So multiplication or division, sig figs. Addition or subtraction, decimal places. But what if we had to do both? So if we had, and this is off the slides, if we had 3 point, calculator. All right, so now we have this. So we've got addition, we've got subtraction, and we've got multiplication. So the way that you do this is you follow order of operations, right? But please excuse my dear Aunt Sally. There are other ones, but that's the one that I remember. So we start with our stuff in parentheses. And so we have parentheses, and we're doing subtraction. So how do we determine how many sig figs our answer is going to have?
You find the lowest one, so it would be the one on the left, right?
Lowest number of
Significant figures. Right?
subtraction, decimal places. Yeah, so lowest number of decimal places. So that is this one. So if we do the subtraction, 782.3 minus 451.88. The whole number that the calculator gives you is 330.42. Okay. If this is part of the lecture this morning too, but you never round until your final answer. All right, but we still need to keep track of how many sig figs this would have if this was our final answer. So what I do is I underline all of the figures that are going to be significant. So if we had stopped here, then we'd get 330.4. That would be our final answer there. But we're not done yet. We now need to multiply this by this. And because we're multiplying, it's going to be the smallest number of sig figs. So this now has 1, 2, 3, 4 sig figs. This last one's not significant because we did the subtraction. So if we multiply these two together, this has 4 sig figs also. Right, they're all non-zero numbers. So 3.87 or 897 times 330.42. Again, the calculator is going to give us some number. Doesn't know how many sig figs we're supposed to have. So that's the whole number that my calculator gives me. 1,287.64674. Big number. Sorry, I know for those of you in the back, it's getting a little low on the board. I'll switch to this side. Actually, yeah, let's do this. Remove. Yeah.
Did you multiply it? It was 330.4, or did you do 330.42?
0.42.
So you did the whole thing.
You do the whole thing? Yeah. Yeah, you do the whole thing because we're not done yet. So just for those of you in the back, this is the answer from that. Or this is the unrounded answer that the calculator is going to give you. And in all likelihood, there's more decimal places going out from there, but that is one reason to keep things in your calculator as much as possible. All right, so how many sig figs should this be? 4. Because this was 4 sig figs, and this, coming from our previous subtraction, only carries over 4 sig figs. So we say this is, right, starting from the leftmost non-zero number, that's 1, 2, 3, 4. And then because this is 6, we're going to round up our 7. So the answer would be 1,288. And even though this does represent the correct number of sig figs, I'm going to convert this into scientific notation. There aren't there aren't very many situations where we do both multiplication or division and add addition or subtraction. Most of the stuff in this class is going to be multiplication and division. Okay.
You remind me, why did you put a 3?
Because if you want to convert this into scientific notation, the implied decimal place is here. All right, so decimal's there, so I got to move this over 1, 2, 3. So that gives us a number.
Because that's be less than 10.
We want it to be between 1 and 10. Yeah. So if you take this 1.288 and you multiply it by 10 raised to the 3rd power in your calculator, it will give you this number back. And so we just want to make sure that we're representing it as the number it actually is. And while I'm on the subject of calculators, there's a shorthand in most calculators for times 10 raised to some power. And on your calculator, that would look like 1.288, right, for this number, and then E, 3. And so that E is just shorthand for times 10 raised to whatever the next number is. It's also useful because your calculator will treat this as a single number, when if you type in 1.288 times 10 raised to the 3rd, it's really treating these as separate numbers, so you can get some order of operation errors. Okay, so that's a quick one on that. I don't think actually on the unit conversion, your unit analysis worksheet, there are any addition or subtraction problems. There's at least one more thing that I want to address. Is it still recording? Right? Yes. Still. Yeah, don't worry if you didn't catch all that. It is being recorded. Okay. So the next thing we need to talk about are units, specifically SI units. SI, I think it's from the French, System or Le Système International de. I'm not even going to try. It's French, and I've never spoken any French. So it's the International System of Units, though, in English. And in like American units, right? In American units, I can never remember what the exact name is. We have, right, inches, feet, yards, miles. Those are all units of length. Right, so we have units of length. And so, like, the smallest one really is an inch. Anything smaller than that is in fractions of an inch. Inch, feet, yard, mile, that kind of thing. So those are like the English units, American units that we use. In SI units, everything is based on, I'm going to try and write these in their like approximate companions here. Everything is in meters. And if you want something shorter than a meter, you use a prefix to say that this is smaller than a meter. So that's what a centimeter is. I'll write this out. Centimeter. This is a meter. So centimeter means that this unit is 1/100th. Right? So like a percent is 1 out of 100. A century is 100 years. This is 1/100th of a meter. So the relationship between a centimeter, so 1 centimeter is equal to 1 times 10 to the -2 meters, or 0.01 meters. Ooh, not a capital one. So the first part actually of the unit analysis worksheet, I'll talk about this now because it's related. These are all, in the first column, they are all prefixes. So the way you're supposed to do this is this is on 1, and then for A, we have a capital M. And when that's used as a prefix for a unit, it's mega. Oops. Mega, so the first blank should say mega. You're familiar with depending on how familiar you are with computers, like a megabyte. Mega, same prefix. And then in the second line, you write what that number, what this prefix represents, and it's times 10 to the 6, or a million. Oh, I didn't give myself enough room here. Then across from that, there's another line, mg. I actually can't see this on here. Right, so then it says blank mg equals blank g. Because I haven't gotten to these units of mass yet, but G is for grams. So this is a megagram, right? And the mega means times 10 to the 6. So 1 megagram is equal to how many grams? A million. Or 1 times 10 to the 6 grams. So the prefixes are modifying the base SI unit to tell you how many of the base SI unit it represents. So like here, 1 centimeter is 1 times 10 to the -2 meters. So that is for part 1. But to go through the rest of these, the important thing to know though is that if you ever see one of these prefixes with M, it's talking about a length, right? However many meters, how far away it is in meters. We talk about, well, I'll say mass. Mass and weight are the same thing, but only on Earth. So weight, pounds, are actually a unit of force. Mass is actually talking about how much matter there is. So if you go to the moon, you will weigh less than you do on Earth. let's go to the moon. I'm down for it. All the time. So mass, though, is the amount of matter. So you have the same mass on Earth as you do on the moon. So when we talk about mass, I mean, you probably think of things like ounces, pounds, tons. In SI units, everything is based on, and I'm writing it up here because the gram is most similar to an ounce. So everything is in grams. And then if you want something, the closest thing that's conventionally used in the SI system that's close to a pound is the kilogram. So this is kilo. Okay, so if I have 1 kilogram, how many grams is that?
Grams or pounds?
Grams. It's 1,000 grams. So kilo means 1,000. Plus 1,000 grams. Now, what if I had a kilometer? Or, as most people say, a kilometer. How many meters is that? Also 1,000. Or we could also write this as 1 times 10 to the 3. The last unit that we need to talk about, is everybody okay if I erase this? You got this written down on your worksheet already? Okay. Because I never leave enough room. So the last one, if we think about volume, so how much space is there in an area, right? You think of, and this actually is the one that we do use in the U.S. But usually it's like a, well, there's fluid ounces, just because everything needs to be confusing in the SI, or in the units that we use here. So fluid ounces, but then there's also like a pint, a quart. I'm using abbreviations for these. This is a pint, is a PT, quart, and a gallon. So don't confuse G. G is always grams. Gallons are GAL. So that you can differentiate that. I think I'll get this right. So the base, does anybody know what the base SI unit for volume is? Use it to measure soda. It's a liter. Actually, I think 2 liters might be closer to a quart. I cannot remember where this fits in. It might be a liter is a pint. But it's rough anyway. I mean, a kilogram is 2.2 pounds. So the liter, though, is the base unit here. And if we want to use something smaller than a liter, generally you use milliliters. Right, so like a 12-ounce can of soda is like 355 milliliters. So liter, is it 2 L's? Milliliter. Okay, so let's do this for this. 1 milliliter. How many liters is that? If anybody knows. Milli means 1,000th. So kilogram means 1,000 of, right? 1,000 grams. Milli means 1,000th. So 1 milliliter is equal to 1 times 10 to the negative 3 liters. And these prefixes, I mean, like I showed you here, you can apply them to anything. So we could have, well, let's use centi for everything, right? So we do centimeter, and still on the screen. So 1 centimeter is 1 times 10 to the negative 2 meters. 1 centiliter, how many liters is that? 1 times 10, yeah, 1/100th, or 1 times 10 to the negative 2 liters. And a centigram, how many grams would that be? One times 10 to the negative 2 grams. So, huh? Yeah, 100th. So centi means 100th of a meter. And it doesn't matter which base unit you're using, it's always going to be the same 1 times 10 to the negative 2. Or we could do it for milli, like we could have a millimeter, a milliliter, or a milligram. That one actually, maybe I should have done that one. I could use way more often. Yeah, does that make sense? So when you're going through on this, my recommendation is always make the unit with the prefix on it the 1, and then write down how many that is of the base unit. That makes sense. So instead of writing this, yeah, well, I'll do this. I'll show you this. So 1 centimeter is equal to 1 times 10 to 100 to the second meters. So if I had 1 meter, how many centimeters would that be? If one of these is 100th, yeah, I heard somebody say it. It would be 100 centimeters. And right, so if you took this and you said one of these is 100th, so 1 over 100 meters equals 1 centimeter. So if I put in instead of 1 centimeter, if I had, let's say, 10 centimeters, this would be 10 hundredths. If I had 100 in here, this would be 100 hundredths, which is 1. Might have lost some of you.
So will they all be 1? On the,
So-
on the right side? Like 1 milligram, 1 kilometer, 1.
Yeah, so I do 1, the capital M is mega.
Yeah.
So 1 megagram, 1 kilogram, and then this one it flips it. So you do 1 centimeter, and then 1 deciliter, 1 micrometer, and then for this last one it's flipped again. So you could do 1 milliliter, and then millimeter, how many meters is that?
I thought 1 meter equals 100 centimeters. So like it takes.
It does.
Okay, so is this right?
Yes.
Okay.
Yes. That is correct also. Yeah. So there's 2 ways to write them. You can have 1 centimeter, and then how many meters is that? That's going to be really, really small because a centimeter is much smaller than a meter. Or you could say I have 1 meter, how many centimeters is that?
Okay.
And you can do that for all of these. So like a kilogram, if you say 1 kilogram is 1,000 grams. So
A kilo is 1,000 grams.
1 gram is going to be, this is 1 times 10 to the 3, it's going to be 1 times 10 to the negative 3 kilograms. Okay. So I want to leave most of this up. We can go over here still. Okay, so those are metric units. And so if you're converting from 1 metric unit to another metric unit, all you need to do is figure out, well, what does the prefix mean? And then how do I go from, this prefix to without a prefix, or even with a different prefix? You can do that too. The table that is on here is, if I'm not mistaken, only for English, or we call them American units, into metric units. So if you have any conversion, say that goes from problem 3. Problem 3, it says convert 5.2 kilometers into meters. You're not going to find it on this table because you're going from 1 metric unit to another metric unit. Or for the same for millimeters into meters. Right? You're going to have to use that prefix to figure out what the conversion factor is.
So can you do 1?
Absolutely.
Okay.
Absolutely. So, yeah, because this leads into the next thing is, okay, what are conversion factors and how do we convert units? Yeah, let's just start with, I'll do 3A for you. So we have 5.2. So this is 3A. We have 5.2 kilometers. And the prompt for this whole section of 3 is convert whatever units you have So I'm just going to leave that. So we have kilometers. We want to convert that into meters. So the way to approach this is first figure out, can we get a direct relationship between a kilometer and a meter? So put in other words, how many kilometers are in 1 meter? Or how many meters are in 1 kilometer? Yeah, so there's 1,000 meters. So if we have 1,000 meters equals 1 kilometer, this is a conversion factor. Right? Because if we had 2 kilometers, how many meters do we have?
2,000.
2,000. If we have half a kilometer, how many meters do we have? 500. Right? To sort of formalize that, and I think I want to do this. There's 2 ways that you can write it out. I'll just do it. So we're going to take this, and we want to multiply it by our conversion factor. Or at least multiply by the top part of the conversion factor and divide by the bottom. And the way that I like to think about this is we have units of kilometers. What are the units that we want? Meters. So knowing that we have this conversion factor to get us from kilometers to meters, we want to get meters, so we put that in the numerator on top. Then we put kilometers is the unit that we want to get rid of. So we put that on the bottom. And now we match in this relationship for these units. So how many meters? 1,000 meters. And that's 1 kilometer. And then getting that number again from here. Because I should have started with something else. But okay, so that will convert this from kilometers to meters. Because if we multiply this, 5.2 times 1,000, we'll get 5,200. Then we'll get kilometers times meters. So this will be kilometers times meters over kilometers. And this is going back to some algebra. But if we have kilometers divided by kilometers, it cancels. Because kilometers divided by kilometers is 1. Right? Anything divided by itself is 1. So that cancels. And we're left with 5,200 meters. Which then we have to, how many sig figs should we have? 2. How many are there?
4.
Ambiguous. But we need to get down to 2, right? So how would I write this in scientific notation?
2.
Times 10 to the 1, 2, 3. Yeah. So that would be your final answer for 1 or for 3A. Nice. Okay, so just to try and illustrate this concept of like this being equal to this a little better, if I take this ruler, right, put this on the board, this is 0, 1, 2, 3, 4, 5. These are inches, by the way. 6, 8, 9, 12. Okay, right? So that's 12 inches, right? So when we say 12 inches, we mean this distance. From here, all the way over to here. That is 1 foot. So this distance is 1 foot, right? So different words mean the same thing. So when I write a conversion factor between inches and feet, 1 foot equals 12 inches. So then I can rewrite this. Again, anything over itself is 1. That's not very useful, but if we rewrite this as 1 foot over 12 inches, we can also rewrite it as 12 inches over 1 foot, because it is, in essence, something divided by itself. So if we flip it upside down, it doesn't change anything. This is useful though, because if we wanted to convert from, do an easy one again, 48 inches, and we want to convert that into feet, it's this same process. So 48 inches times, we're going to be multiplying by something on top, dividing by something on the bottom. Which unit do I put on top? Feet, because we want units of feet. And then what goes on the bottom? Inches, because we need to cancel out these inches. And then I look over here and I see, oh, well, I don't want this one, right? Because this doesn't match feet, inches. We use this one. So 1 foot over 12 inches. Answer would be 4 feet. But if we wanted to do 4 feet, it's the exact opposite process. So instead of putting feet on top, we put feet on the bottom, inches on top, and then we're multiplying by 12, dividing by 1. So that's this one. So our conversion factors, because they equal the same thing, can be used in either direction to go back and forth between those units. Obviously, it's a lot harder to demonstrate that 1,000 meters on a kilometer. My whiteboard's not that long. But all of these units that are equivalent. So if you look on here, right, this table of lengths that are equivalent, if you drew out 30.48 centimeters, it would be the same length as 1 foot. So there would be, in this same distance, 30.48 centimeters. So 30.48 centimeters is the same as 1 foot, it's the same as 12 inches. Hopefully that helps someone and is not just more confusing. Like the same thing with mass though too, right? If I took something that weighs something out that's 1 kilogram, and I put it on another scale that weighs in pounds, it's going to be 2.205 pounds. Those things are the same. They're just different words for the same thing.
What's the one below the meter, the NS?
Oh, N? N is nano.
Is that like minute?
Oh yeah, we didn't talk about units for time. So the SI units for time are the same as the units that we use. English units for time, it's seconds, minutes, hours, days. So S is seconds. MIN is minutes. H is hours. Or HR. This is one that changes depending on where you look. Okay, I think that is everything that you need to get started on this. Now, the other thing that I do want to add, that's all that I'm going to do with this. Okay, there are compound units. Compound units. So, if you're looking at houses or apartments or whatever, the size of that house or apartment is measured in square feet. Right? That's the surface area of the floor in the house or apartment. So let's say you're looking at. Let me just throw that real quick.
Another shirt to the lab.
Lost the lab. Let's say you're looking at an apartment and let me do it even better. You're going to study abroad, England or somewhere else. They show all of their floor plans in square meters. So you look at a floor plan and you're like, it says it's, I don't know, I'm just going to pick a number. 54.5 meters squared, right? Square meters. Meters squared, square meters, same thing. So you're like, okay, well, how big is that space? You want to, your frame of reference is square feet. So how do we convert this into square feet? So that's where you would turn to this chart. This has your conversions between metric units and English units. So if we look on here, we don't have anything for meters squared specifically, and that's fine. We can still just use the conversion between meters and another unit. Do we have meters and feet on here? So we don't have meters and feet, but we do have meters and inches, right? And we know if we get to inches, we can get to feet. The other thing we could do is we could go from meters to centimeters, and then from centimeters on here, we have centimeters to feet. I'm going to go with that first option. We're going to go meters into feet, inches first. So the relationship, so 1 meter equals 39.37 inches. Okay, so I'm going to write my X. We got our line. So how do I convert from meters to inches? What do I fill in here?
Inches on the bottom, meters on top.
Right? Inches on the bottom? Or no, not inches on the bottom. Yeah. Meters on the bottom.
Meters on the bottom.
Yeah. Because we have meters here. So this will be 1 meter. This is 39.37 inches. Now the problem is that this is just meters. This is meters squared. And you can also think of meters squared as meters times meters. If you're going to calculate the area of a square, if it was 1 meter, let's say so you've got a rectangle, right? And this is 2 meters, and this is 1 meter. How do we calculate the area of the rectangle?
Multiply the two sides together.
Multiply the two sides together. So 2 meters times 1 meter, this would be 2 meters squared. So we need to convert meters to meters squared twice. So, because right, meters times meters. So we need to cancel it out twice. So we just repeat this. 39.37 inches over 1 meter. Then that'll get us to inches squared. Because now we've taken inches times inches, and we want to get to feet. So right over here, 1 foot is equal to 12 inches. So not a lot of space here. I think I can make it work. We're going to do, again, we have to do it twice. Because we've got, this will be inches times inches, so this will be inches squared. So we need to cancel out inches twice. So again, what goes on the top? Feet, the unit we want. And on the bottom, inches. And this will be the same. Do not flip these. If this is feet over inches and then you do inches over feet, you're like canceling out the whole conversion. You'll undo what you just did. It's happened. So 1 foot, 12 inches, 1 foot, 12 inches. And then your final answer there will be in feet squared. So I'm just curious now, 5 times 39.37 times 39.37 divided by 12, So it'd be 586 square feet. So it's probably a smallish studio. Depending on the prices, you may or may not want that. Okay, does this make sense? There are problems on here that you have to do.
So do I have to like measure a cat or?
No, you're told the volume of kittens that you have.
Oh, so we just.
So if you do it, for meters squared, we had to do it twice. For meters cubed,
We do it
3 times. And again, they should all be in the same orientation. Right? Don't flip one of these. The one unit that I do want to call to your attention actually has to do with the milliliter. A milliliter is the same thing as, so 1 milliliter equals 1 centimeter cubed. So there's a problem.